Thank you for the introduction and thank you for having us. I know that it's a bit late and everybody's tired, but I think you're gonna maybe like our presentation. So what we're gonna present today is actually a research paper that we did during our masters at the University of Amsterdam. And it focuses mainly on WSL2 and the security around it, and if it's actually beneficial or if it's a liability. The authors actually of this paper, there are 4 people, out of which 2 are present here. And everyone from here is actually a student at the University of Amsterdam or graduated from the University of Amsterdam. Whoops. The first person is Max van der Horst, which is an incident responder. Myself, Bratean, a threat intelligence analyst. Jeroen van Sanne, an ethical hacker. And Bratean Pauls, a security analyst. So what exactly is WSL? So we're going to use our savior, of course, Wikipedia, that says Windows subsystem for Linux, WSL, is a compatible layer for running Linux binary executables in L format, natively on Windows 10, Windows 11, Windows Server 2019, and Windows Server 2022. So generally what it says is that a Linux system inside, it's a Linux system inside a Windows environment that can run multiple distributions. There are actually 2 versions of WSL2, WSL actually, that appeared, the first one in 2016 on Windows 10, and WSL2 appeared in 2019. But what's actually the difference between those 2? So WSL1 actually works as a translation layer. So think of it like a wine fashion kind of system, where the Linux system actually is going to be a translation between the Linux system and the Windows kernel, so the syscalls. And then how does it do this? It uses picker processes and picker providers. What are those? So picker processes are the bin bash, and picker providers are the actually drivers that actually do the translation. So LXSS system and LX core system. When it comes to WSL2, it's a totally different architecture, and it's using actually virtualization, using Hyper-V, so actually a type 1 hypervisor, and a lightweight virtual machine to actually improve deployment and quick iteration. And how it is done, actually, the distributed kernels are maintained by Microsoft, so everything is open source. So if we look a bit inside of it, how it works, we have 3 components. The first one is the WSL.exe, which is the GUI, where the user can actually interact with it. And what it does, it takes the SD-in and puts it in the bash using vsocket. Then is the LX Manager service that actually does the conversion between the file systems and keeps count of the Linux distribution. There's the host computer that does the emulation of the Linux kernel, but also starts the virtual machine. Then comes actually the second component, which is the file system. So how does the Linux WSL actually communicates with the Windows? It actually uses a protocol, NAMP protocol, and uses a server client, and you can access both file systems from both systems. And the last component is actually the virtual machine. This being said, what actually is the addressed issue that we are trying to do here? Because of the actual translation in WSL1, the things that appeared are the bashware, which is actually malware in Linux that can be run in Windows environment and can be actually bypassing the Windows security. So actually this went to the process of actually developing WSL2, which, as I mentioned, it doesn't use anymore picker processes, but instead it serves as a completely separate VM. However, security researchers from F-Secure did a research on how you can use WSL2 to actually increase the attack surface and actually bypass the security of Windows. So in the end, how secure is this redesign, and how does it impact your Windows machine? To take a closer look to what F-Secure did, firstly, it actually used a PowerShell to install stealthily and enable WSL2. Then it downloaded and installed the Linux distribution. Then it installed a backdoor, and in the end, exposed the backdoor and started doing C2 calls. So here starts our research, where the test environment was Windows 10, 21H1, WSL2, and Ubuntu 20.04 LTS. And we started with the threat model of F-Secure, where there was a compromised Windows 10 machine, and the attacker had the full access to it. So in the end, how did we actually test this? We created this thing of a baseline called attacker stories, which were ways to test the security of Windows and see how we can bypass it. and also what we can see inside the Windows environment. So we created 3 levels of security: default security, so whatever the Windows image comes with; event logging audit policies, so think about Windows Firewall, process creation, PowerShell, and then a premium security product. Unfortunately, we couldn't take actually premium, but we used sysinternals to actually emulate this. To clarify a bit more, in the phase 1, we defined the attacker stories. Then we did actually experiments with the attacker stories. Then we create a real-life scenario, how we could use this, and in the end, evaluated the Windows security. So in the end, we came with these 8 attacker stories, which we divided on network, on processes, resource management, and system components. So the first one is the Windows Firewall bypass. And here, as the title says, we actually tried to block a IP domain in the Windows Firewall and then tried with WSL2 to bypass it. And guess what? It was a success. And you can see here, we tried to access a domain that was blocked in the firewall. And then we tried to do the same with the curl command inside the WSL2. And it actually went on WSL, and the same curl command in CMD, it was blocked. So what did Windows see? In the default security, nothing. In the policy changes, we actually could see in the firewall that there was a connection from the WSL2 private IP to the blocked IP. And in the premium security with the sysinternals, we can see that there was a connection to the block IP from the SAV host.exe. And why is that? Is it because of the architecture of the hypervisor? Because each one of these virtual machines have a virtual NIC, and then it connects to the virtual switch of the Hyper-V, and then to the physical NIC. So it's a different layer, so that's why we couldn't detect it. Now, my colleague Max is gonna actually continue with describing the attacker stories.
Thank you. Good afternoon, everyone. I'm going to run you guys through the remainder of the attacker stories that we actually had. The first one being the reverse shell. So we did an experiment with a reverse shell to test whether we could exfiltrate files through a reverse shell without being detected, based on the experiment that my colleague just explained. This was also a success. Basically, what we found was that under the default security of Windows, port forwarding and the connection was kind of logged, but it was not detected. Under policy changes, nothing actually changed. And under the premium security emulation, it was detected. TCP view could see things, but nothing was actually triggered. This is interesting because that verifies the firewall bypass and other things. Basically, what we verified it would be was that what my colleague explained, that the traffic goes through the VNIC to the physical NIC, and that Windows kind of looks at the traffic that is going through the physical NIC, but in promiscuous fashion, but that it doesn't actually take action on it. Next, we had an experiment surrounding the SSH connections, which is in behavior kind of similar to the previous experiment. This was also a success. So the reason we did this separate to the reverse shell was because SSH connections can actually be somewhat more stealthy and reliant rather than a reverse shell. As I said, this had kind of similar behavior. It was logged, but no real action was taken. So the SSH connection could be seen alongside the port, but it wasn't really obvious that anything happened. And if a threat actor adds the keys to WSL, this is actually completely fine. Furthermore, the next experiment we had was a research exhaustion experiment. So we wanted to see whether the resources of Windows could be exhausted from WSL, with the goal of slowing down the system and triggering a restart or whatever. The motive that the threat actor could have in this use case is to coerce a user into restarting the machine, which actually confirms changes made to the system, such as the disablement of shadow copies. So we wanted to see whether we could exceed the 80% CPU RAM usage on Windows, which was actually the case. So in the end, it's very simple. What we did was we fork bombed it, and this is actually a known memory leak issue inside Windows. Microsoft knows about this but refuses to patch it. Basically what happens is that once the instance is fork bombed, the LXSS manager starts handling these threads, and the front end becomes unusable. So if this front end is closed, it is not the case that the entirety of WSL is closed, but only the front end, which decouples the front end from the back end, and actually allows for permanent 100% usage of CPU and RAM. As you can see in the image, it actually does nothing. This is what it looks like. So the only thing WSL says is that the resource is unavailable with a 100% CPU usage. There's nothing you can do about this, only restart your machine. Next, we wanted to investigate whether we could see any processes from WSL inside Windows. The reason we wanted to do this was because we wanted to see what the potential was for antivirus solutions to actually recognize malicious behavior. This was also, well, from an attacker perspective, a success, because Windows couldn't really see anything except for the VMM and the WSL.exe processes. If we used a premium, if we used sysinternals, WSL host.exe was joined that list, but other than that we couldn't really see anything. As you see in the image, it is only WSL.exe creating events, but this covers up any activity inside WSL, which is interesting for attackers, as AV doesn't detect this, and furthermore, it's just an abstraction layer. So, building on top of that, we wanted to see to what extent we actually could use malware and hacking tools inside WSL without Windows detecting this. We could, spoiler alert, but under default security, it was detected inside Windows but not inside WSL. So this meant that we could download malware. For example, we used the ICAR binary. We could download this to WSL and it would not be detected, but only if we started executing this inside Windows, it would be detected. Under policy changes, Windows did log the specific events, and the sysinternal suite could see what was happening. But potentially this is interesting because as long as the malware is Linux-based, you can run this without any issues. For Mimikatz, this was the same thing. So we attempted to launch Mimikatz from WSL inside Windows. And this can be defined as a partial success, because what actually happened was that antivirus solution inside Windows did detect the Mimikatz being run, but only after it was launched. So yes, the detector of threat actor would be out in the open, but credentials would be already stolen, so it's last resort maybe. That's what it looks like. We also had some unsuccessful experiments, among which the evaluation of leakage through memory. We wanted to see whether we could actually access memory from WSL inside Windows and vice versa. This isn't the case because of the architecture, so Hyper-V has separate page tables for each VM, which actually makes sense, but that doesn't work. And the other thing was exploiting environment variables. So we wanted to see whether we could set up the environment variables of WSL or of Windows for confused deputy-like issues. So if we could trick Windows into using environment variables set by a threat actor with higher privileges. And this is just not persistent. It's only set once WSL2 is spawned, and after the instance closes, it is gone again. So that didn't really work. So now that we've had all the attacker stories, we can put it together into a scenario. The first of which is a ransomware scenario. So what we came up with is actually an already compromised system, as we mentioned, but that the firewall bypass can be used to download ransomware. This can be executed on WSL. It can be scripted that the shadow copies are removed, so any backups can be disabled. Then we fork bomb the instance to force a restart of the system. And after the restart, the system changes of the shadow copies are confirmed and we can start encryption process. The second was a data exfiltration scenario. So it's actually somewhat simpler, but for persistency use, you can create a cron job inside WSL. You can keep it running in the background. WSL actually makes an automatic mount to the C drive, so you can use that cron job to access the C drive on Windows and exfiltrate data to another system, during which you again bypass the firewall. It's detected nowhere. So this you can actually use to send data to command and control center or get whatever you want. So to conclude whether WSL is secure or a liability, there are some good points and there are some less good points. So the good points that we had is that most importantly, bashware attacks are no longer possible or viable. That's interesting. There's separation of memory, which is nice. Changes in Windows are picked up on very well in terms of logging. And there is a possibility for Windows to improve premium security to actually monitor changes happening inside WSL as the sysinternals suite can do it. So why can't the premium vendors do it? The less good points, however, are that there are some design decisions that we consider poor. There's very bad documentation and the network traffic bypasses the firewall, which is not good. There is no fully integrated logging, so not everything from WSL is actually visible inside the event viewer of Windows. And because that happens, it becomes a potential blind spot for antivirus solutions and possibly EDR. So it's not insecure, but it may need some reconsideration on design and user support to make it more secure and to help users harden their systems. So there was some future work when we wrote this paper. So we actually want to continue this research on WSL by enhancing the current experiments to reevaluate after a certain period what changed and see if there's extra documentation. We also want to introduce new experiments, such as with the 9P protocol, because we had no, in the set time frame, we had no room to actually go in depth on this. We want to actually take premium security solutions and test with these solutions whether the results differ any from the sysinternal suite. And we wanted to do this with the latest version of Windows, as the version that we used for this paper is by now somewhat outdated, so maybe something changed. And yeah, we really hope that in time there's extra documentation, as this was very time consuming. But for now, we want to thank you for your attention, and we will be open to questions.
Couldn't we have something else to help the WSL2 as to not have as many problems, as in the documentation and the other parts? Isn't there something to help the WSL2 to help not be as much of a threat?
I'm not sure I fully understand. You're saying that we should help with the documentation to add
no, like another program to help the WSL2 to repair its problems, or something that can compensate it.
Oh, yeah. So because WSL2 in the end is a Linux system, you could harden your Linux system as well. So that will definitely make it more safer in the Linux system, but still there are problems like bypassing things, you're still going to bypass. And also, as Max said, if you actually take the logging from the Linux system, you're still going to see the traffic and everything because it actually logs that. So that could be useful. That's, yeah.
Is this program safer than normal Windows or not?
If WSL is more safer
Yeah.
than the normal Windows?
Yeah, or a normal other operation system.
Well, it's a Linux system, so it's as safe as you configure it in the end. But also the definition of normal Windows, I'm not sure exactly what you mean, like Windows 10 machine, Windows 11 machine. So to be honest, I don't know exactly what you refer with.
Windows 11 machine.
Okay. Well, yeah, we can say, in our opinion, maybe it is, but having WSL2 there, it could be a liability in our opinion as well.
Okay, thank you.
Okay, so I have a question. You've mentioned an automatic mount of the C drive in the /mnc, in the /dev environment. That's frightening, honestly. Does it have write permissions? Or like, what permissions does it does?
Yeah, you have full, what user permission you have full permission there as well.
So if WSL, let's say I've seen lots of people using WSL, use it directly as root and not bother setting up users, which again is a very bad choice. If hypothetically a malicious attacker could have run a process on that WSL machine that could have had full write access to the Windows machine too, to the C drive?
Yes.
That's horrible. Also, one more question if you don't mind. I've been Windows clean for a few years, so I don't know how this works necessarily. But you've mentioned WSL1 is like a wine type system, or it's a translation layer, not an emulation, not a virtualization. So was that better for process monitoring? As you've explained, the logging on WSL2 for Linux processes is horrible. Was WSL, like, were processes more visible to antivirus solutions, hypothetically, if they were to be malicious?
Yeah, that question actually is answered by somebody from Sans. It actually did a research on that, and yes, the processes are better monitored in the event logs, because in the end, it's just a translation, so events still happen in the Windows environment.
Yeah, exactly. So.
Yeah, so yes.
Okay, thank you, thank you.
Hi. Here, I'm Dan. Here. So, really nice research, thank you. I wanted to ask you, in their checkpoint research in 2017, basically they said that the WSL1 was actually enabled, but you had to like just tick like developer options, it was there, and the ransomware could actually do it for the user automatically. What about WSL2? Like if I have like a fresh Windows installation, Windows 10, Windows 11, is it enabled? Is it disabled? Do I have to enable? Do I have to download it?
Yeah, there are a few more steps that you have to take in WSL2 because the Linux kernel doesn't come with Windows. I'm not sure about Windows 11 if it comes right now. You have to actually download that, but F-Secure research, it was specifically for that, and it showed how a clean installation can be actually, you can install the WSL2 in a stealth mode, you can actually install a distribution in stealth mode, and then you start actually hacking with WSL2. So in the F-Secure research, our research is based on F-Secure research, meaning over F-Secure research. So they actually show the initial access and how you can do that.
Oh, so basically for WSL2, it's exactly the same, like if you manage to run the payload, you can just
yeah,
launch.
exactly. It's just a few more steps, but still the same thing.
Thank you.
Thank you. Would you consider that it's safer to run Linux in a virtual environment rather than VSL?
Well, in the end, it's a separate VM, right? So I would not say particularly it's safer to run Linux separately, but considering the design that Microsoft made around around WSL2, I would say Linux is in itself more secure than WSL, but that's not because of Linux, but that's because of the underlying architecture.
Yeah, but in a VM, like you're depending on the hypervisor and everything, like would that be safer rather than going for WSL?
Sorry, could you repeat?
Like, would you rather rely on the VM rather than VSL?
Well, WSL is a VM in the end, but looking at, I would rather have a VirtualBox, a different type hypervisor than Hyper-V, yes.
Okay, thanks.
Hello. One more question here. What's the likelihood of encountering this pretty much lab environment experiment in the real life? I mean, are there products already using these layers so that, you know, somebody can nowadays abuse it without installing it on purpose?
Yes, so if you want to use Docker on Windows, you need WSL2. And then immediately, if a developer wants to try Docker on Windows, you will immediately have installed WSL2. So that's easy.
That's already a live one, it's not really.
Yeah, exactly.
Okay.
So it wouldn't be a clean installation. You immediately would have access to WSL2.
Thank you.
Thank you for your research, really interesting. I'm a heavy user of WSL as a software developer, and it's really making my life easier, so I hope no one takes it away. Do you think WSL is less secure compared to if I would like use Hyper-V and install a Windows Hyper-V and install some Linux distribution for cross-compiling? Because the process to get to it, I think, is not straightforward if you want to intrude it. So you need to enable Windows feature subsystem for Linux, you need a reboot, and then as soon as Windows 11, I think you really just need PowerShell WSL install and you get everything. But for me, it's like the same if I would use Hyper-V.
I would say purely from an operational perspective that using Hyper-V from scratch is more secure, mainly because you have to think about what you configure, right? So things like the automatic mount to C drive, it's fine if you do that, but if you do them consciously, it's not something that happens in the background without you knowing, right? So just using Hyper-V and thinking about what you configure is, in my opinion, safer.
Okay, thank you.
All right, if we don't have any more questions from the audience, thank you so much, Radek and Max. Give it up.